Let's look at example 5.44, where we're setting up a triple over a general region, where the region is described using cylindrical coordinates. We can start by reading the description. They describe in words the region. They tell us that the region is bounded below by the r theta plane. That's the same thing as the xy plane. It's bounded above by the sphere. Rho equals 4, so sphere of radius 4 centered at the origin. That's this blue sphere over here. And then our region E lies inside of the cylinder. R equals 2 sine theta. And then that's this vertical cylinder here. R equals 2 sine theta. So we want to be inside this guy, bounded above by the sphere, and then bounded below by the xy plane. Let's take a projection of E in the r theta plane, and then that's going to produce the base of this cylinder, which is a nice circle. Remember that sine is 0 when theta is 0, sine is 1 when theta is pi over 2. Therefore, the circle will produce its largest value along the y-axis. When theta is pi over 2, 2 times 1 will be 2, and so that's the furthest that the point will be from the origin. So if this point is being produced at pi over 2, this point is produced at 0, then this is all of the acute angles, and then this would be all of the obtuse angles. That's telling us that we can take a range of values for theta from 0 to pi. If we pick an arbitrary value for theta between 0 and pi, we can draw in that ray. And then that ray will be in our region dr theta, starting at the origin and then going all the way out until we get to the curve r equals 2 sine theta. So that produces the bounds for r, lower bound of 0, and outer bound of 2 sine theta. So these are inequalities which describe the projection of E in the r theta plane. All right, good. So again, for that fixed arbitrary theta naught, find a point on that ray. That's going to be a point in the base of our region E. Therefore, z values will be allowed to be 0. Then moving from that base, lifting up, staying inside the cylinder until we get to a ceiling. And the ceiling is going to be provided by the sphere. And we know that that sphere, x squared plus y squared plus z squared, is equal to 4 squared. Can be solved for z. You have to solve for z, not z squared. And so you get the radical of 16 minus r squared is z, and then that's going to be the upper bound. So from the description in words to finding a projection to then being able to write down inequalities to describe E, once we have these inequalities in our hand, the only thing that we need to remember is that we are setting up a triple in cylindrical coordinates so that a convenient order is dz, then dr, and then d theta, our typical read from the bottom to the top. And the only thing that you need to remember is that you pick up a factor of the variable r in that volume differential. Good, and then setting up the triple is straightforward. Very nice.